Example 5.4.1. This one says, an investment offered a 15% rate of return over the last year. If inflation was 10% over the same period, what was the investor's change in purchasing power? That is, what was the investor's real rate of return? Okay, what's going on with this one is that the interest rates that we see on our investments are not necessarily the rates that we are most concerned with. The interest rate measures the change in actual dollars that we'll have, right? Assuming it's an effective rate, or we can convert an APR to an effective rate. But most often what we are concerned with is not necessarily the number of dollars that we end up with, but what we can buy with those dollars. So there's another moving piece to this puzzle when we're considering what we're going to get out of an investment. We not only want to know the actual change in the dollars that we're going to have, but what we can purchase with them. And so that extra variable is what is happening with general price levels, right? And changes or a general increase in price levels is what we call inflation. And in a healthy economy, prices do tend to rise over time at a moderate rate, and it can get out of control. And sometimes you can have deflation where prices actually fall, like Japan has been dealing with for a couple decades. But for the most part in the US, we've been dealing with some level of inflation. And it's been worse at times than others, but it is something we need to factor in. So that's what this problem is getting at. It's we want to add in another layer here of not only what is our return on this investment, but then what happened to price levels over that same period. And so what was the actual change in purchasing power? How much more stuff could we buy, considering both the rate of return on the investment and the change in prices over the same time period? Right, and that relationship, the relationship between those two things, the what we call the nominal rate of return. Nominal means in name, and it's the stated rate, so that would be like the APR that we observe. And then the rate of inflation, the relationship between those two that gives rise to the real rate of return, where the real rate of return measures our change in purchasing power given those two, is given by what we call the Fischer Equation, named after the economist Irving Fisher, who was the first one at least to write it down and make it explicit. And it is this guy right here, equation 5.03, where 1 plus the nominal rate, that's the stated rate that we see in our investment, is equal to 1 plus the real rate, where the real rate is the actual change in our purchasing power, times 1 plus the inflation rate, so the rate of change in prices. So this gives us a relationship between these three variables, where the rate that we see is a function of, is a combination of the real rate and the inflation rate. Well, this is an equation, so if we have any two of those variables, we can use this to solve for the third, which is exactly what we're going to do here. In this case, we know the nominal rate. We had a 15% rate of return on the investment. We know the inflation rate. Prices rose 10% over that period, so we can use those two pieces to solve for the real rate. All right, so let's write out the Fischer equation first, and then we'll adjust it to what we actually need. So 1 plus the nominal rate is equal to 1 plus the real rate times 1 plus the inflation rate. So for this one, we can go ahead and plug in what we know. The investment offered a 15% rate of return. That's the rate of return that we see. That's the nominal rate. 15% expressed as a decimal is 0.15. So 1 plus 0.15 is 1.15. So 1 plus the nominal rate is 1.15. And that is equal to, let's actually line this up a little better so it's more obvious where things are coming from. And that's equal to 1 plus the real rate, which is what we want to solve for, times 1 plus the inflation rate. Well, inflation was 10% over this period, and 10% expressed as a decimal is 0.1, so that's 1 plus 0.1, or 1.1. All right, so we want to solve for the real rate. What we'll do is begin by dividing both sides by that 1.1. And so we have 1.15 divided by 1.1. Of course, this cancels out on the right-hand side, and we are left with 1 plus the real rate. The last step is just to subtract 1 from both sides. And so we have 1.15 over 1.1 minus 1 is equal to the real rate. Right. If we plug that in to the calculator, 1.15 divided by 1.1 minus 1 is going to give us 0.4, is that 55? Yeah, 0.455. Oops, 0.0455, there we go. Which this is expressed in decimal format because we converted all the other rates to decimal format. And so if we want to look at that in percentage terms, that is 4.55%. And that is our change in purchasing power. Right? Although we did earn 15% on this investment, we could only buy, because prices over the same period rose 10%. We earned 15%, but prices rose 10%, so we can only buy 4.55% more stuff. Right? Now, you can get pretty close to this. In fact, it's even called a Fischer Approximation if you just take the rate of return minus the inflation rate. So in this case, our rate of return was 15%, inflation was 10%, so 15% minus 10% gives us 5%. And that is an approximation in the change of our purchasing power. But it's not quite exact. To see why 4.55% is more exact, we can kind of filter this through something that we would buy. Apply these same numbers to something that we would use our money to purchase, and we'll see that it actually comes down to 4.55%. So let's just, to put it in a little more concrete terms, let's just say we're going to, in this investment, we're going to invest $100. Right? And we're going to earn 15% on that guy. So if we have just this 1-year investment, we invest 100, we're going to earn 15%. Right? If we're investing $100, they're going to pay us 15% interest. Well, 15% of 100 is 15, so 1 year down the road, we're going to have $115. Okay? So we're going to be better off by 15%, in this case $15, because I chose a very convenient starting point of 100. Now let's say over the same time period that the price of gas increases 10%. All right, price of gas increases 10%. That means that when we made the investment, when we invested the $100 at time period 0, gas was, let's say, $2 per gallon. Okay. Then 1 year later, I'll use a little I for inflation. It's going to increase 10%. 1 year later, when we get a payoff of $115 from this investment, gas has increased 10%. Well, 10% of 2 is 0.2. And so the price of a gallon of gas is going to be $2.20 per gallon, right? It increased 10%. All right, now let's look at what happened to our purchasing power over this same period. At time period 0, so today, when we made the investment of $100, we had $100 and gas cost $2 per gallon. So how many gallons of gas could we buy? If we take that $100 and divide it by $2 per gallon, we find that we could have bought, not $50, that's 50 gallons of gas that we could have purchased with that $100 when we made the investment. Now 1 year later, we have $115 and gas is $2.20 per gallon. So how many gallons of gas can we buy now? That's $115 divided by $2.20 per gallon. And that is not something I can do in my head, so let's plug it into the calculator. 115 divided by 2.2, so 52.27 repeating. Right, so we could buy 50 gallons of gas at the beginning with our $100, and then with our $115, we can buy 52.27 gallons. Now, what is the percentage change in the amount of gas that we can actually buy? Well, our percentage change formula, just way back in the day from one of the first algebra classes you took, is something like the newest value minus the old value divided by the old value, or the value you started with. So we take the value we ended up with. We could buy 52.27 gallons of gas. At the end, to start out with, we could buy 50 gallons of gas. So we can buy an extra 2.27 gallons of gas, and then we divide that by what we started with. We could buy 50 gallons of gas, and we'll get the percentage change in the amount of gas that we could buy. So let's take that 52.27 minus 50 equals 2.27 and divide it by the 50 that we started with. And sure enough, we can buy 0.0455 or 4.55% more gas. All right, so that's what's going on. The interaction between the change in our wealth, which is the return on the investment, and then the change in price, the interaction of those two things gives us the change in purchasing power. And this Fischer equation that we use to calculate the exact rate gives us the exact amount of the change in our purchasing power, which we can see with a sort of concrete example with gas.